Now let us see limits and L'Hopital's rule. Now, what values does the function f of x, okay, um, approach at the variable x, uh, as the variable x approaches c? So that is limit x tends to c. And a one-sided limit as uh, is the positive sign, that is a limit x tends to c plus f of x, um, meaning the x value is greater than c. Okay, and whereas a negative sign means x approaches uh, x approaches c from left, so which is a limit x tends to c minus f of x, where x is decreasing, x is less than c. Okay, and now let us evaluate the limits. Now the limit x tends to infinity e to the power of minus x. So e to the power of minus x is 1 by x. Okay, so which can be written as limit x tends to infinity 1 by e to the power of x. So as x gets larger and the larger e to the power of x gets much larger, so this would grow to infinity, so it is 0. Now limit x tends to infinity 6x cube minus 8x square divided by 2x cube plus 4x square. Okay, at first instance, it might seem necessary to apply L'Hopital's rule. So since 6x cube minus 8x square and 2x cube plus 4x square both grows indefinitely larger and larger. So let us apply that. So we can hence solve this by dividing numerator and denominator by x cube. Okay, we divide by x cube, both numerator and denominator. So this becomes a limit x tends to infinity. So this is 6 minus 8 by x divided by 2 plus 4 by x. Okay, so now again substituting it to infinity. So this becomes uh, 8 by infinity, which is 0. So this is 6 minus 0 divided by 4 divided by infinity, which is 0, which is 2 plus 0, which is 6 by 2, which is 3. So this problem requires L'Hopital's rule because when you substitute the limit as x tends to 0 for uh, sine x, it is 0. Okay, this becomes 0. And limit x x x tends to 0, this also becomes 0. So which this problem cannot be solved by this. Now by applying L'Hopital's rule, so this is d by dx of sine x. Okay, and then apply limit x to 0 and d by dx of x, and then substitute x as 0. So which is this is cos 0, and this is 1. So which is 1 by 1, which is 1. Okay. Now we'll look at another problem. Now this is limit x tends to 0, 2x by e to the power of x minus 1. Again, this problem also requires L'Hopital's rule. So we'll differentiate this with respect to x and differentiate with respect to x. So, and then apply the limit. So d by dx of 2x will be 2, and then substitute x as 0. And since we don't have any x term, we need not substitute here. So this will be e to the power of x, and this x 0. So that will be 2 by e to the power of 0, which is 2. Now let us solve this problem. Again, note that uh, here when you substitute x as 2, okay, it can be solved. So here we need not use L'Hopital's rule. So while substituting it, so this is 2 square minus 3 into 2 plus 6. This is divided by 2 square plus 3 into 2 minus 2, which is equal to 4 by 8, and it is 1 by 2. Okay, and now let us look, can we apply this? Yes. So if you look at this, when I substitute x is equal to 0, we get this is root 144 divided by root 9. Okay, so we need not apply L'Hopital's rules here. So this is 12 by 3, which is 4. Let us see this problem. Now you can see this numerator is in the form of a square minus b square. So let us split that. So limit x tends to 4. This is x plus 4 and x minus 4. And then the denominator is x minus 4. We can cancel this out and then substitute x as 4. So we get this as 4 plus 4, which is 8. Okay. Now look at this problem. Here, let me divide the whole thing by x square. So this becomes 2 minus 3 by x divided by 4 plus 9 by x. Now, when you substitute x as infinity, so this is 2 minus 0 divided by 4 plus 0, which is equal to 1 by 2. Now, let us look at another problem. Applying limit as x tends to 1, ln of x divided by x minus 1. So here we need to apply L'Hopital's rule here. So differentiation of a log x, that is 1 by x, okay, and this is 1. Now let us substitute x as 1. So this is 1 by 1, which is 1. So let us have a look at another problem. When limit x tends to 0, tan x by x. Okay, so we need to apply the L'Hopital rule here. So limit x tends to 0, differentiation of tan x is secant square x, and this is 1. So when you substitute x as 0, so the secant square can be written as 1 by cos, and cos 0 is 1. So it is 1 by 1. Okay, so that is the answer. Now let us see the next problem as limit x tends to infinity. 2x power 4 and 4x square plus 6 divided by x power 4 and 2x square plus 3. Now, if you look at this, I can divide by x power 4. So limit x tends to infinity. So this becomes 2, and this is 4 by x square, 6 by x power 4, and this divided by 1 plus 2 by x square plus 3 by x power 4. So when you substitute infinity, so this is 2 by 1, which is equal to 2. Okay. Now let us see one more problem as limit x tends to infinity, x by e to the power of x. Again, we can apply L'Hopital rule here. So differentiation of x is 1, and this is e to the power of x. So this is 1, and when you substitute, this will be 0. Okay. When you substitute x as infinity. Now, let us apply uh, as limit x tends to 0, square root of x plus 4 minus 2 divided by x. Okay. Now, let us multiply the conjugate of this. That is square root of x plus 4 plus 2. Okay. This is divided by square root of x plus 4 plus 2. So in the numerator, you get limit x tends to 0. That is x plus 4 minus 4 divided by, this is x into square root of x plus 4 plus 2. Yeah. Now, you can cancel out x here and then substitute x as 0. So you get 1 divided by square root of 0 plus 4 plus 2, which is equal to 1 by 2 plus 2, which is 1 by 4. We'll see another problem here as limit x tends to infinity, 8x power 5 minus 3x cube divided by 2x power 6 minus 9x square. Now, I can see that I can divide by x power 6. So this is limit x tends to infinity. So this will be 8 by x minus 3 by x cube divided by 2 minus 9 by x power 4. Now, when you substitute it's infinity, so this will be 0 by 2, which is 0. Okay, now a limit x tends to infinity, e to the power of x minus e to the power of minus x by x. So let us again apply L'Hopital's rule. Okay, so limit x tends to infinity. This is e to the power of x. This is minus and minus plus e to the power of minus x divided by 1. Now, when you substitute this, so that is x as 0. Sorry. Okay, we substitute x as 0. So that will be 1 plus 1 divided by 1, that is 2. Okay. Now, let us see the next problem. Limit as x tends to pi by 2, 2x minus pi divided by cos x. Okay. So, we got to apply L'Hopital's rule. Differentiation of 2x is 2. Okay. And then Cos x is minus sin x. Okay, when you substitute x as pi by 2, which is 1, so this is minus 2. Now limit x tends to infinity, ln of x divided by x. So differentiation of, again we need to apply L'Hopital's rule. Differentiation of log is 1 by x, and this is 1. So as x becomes large in the denominator, it becomes 0, right? So 0 by 1, which is so please do comment, like, and share.